Okay, so if we look at any oblique projectile motion, this is something this we have seen oblique projectile motion. And if someone observes somebody wakes up late, you start observing oblique projectile motion from the moment it has reached the highest point. You see only this part of the motion. And what would this part of the motion be? This is nothing but horizontal projectile motion. The horizontal projectile motion is nothing different. It's same thing. It's motion of a object moving under gravity. And if it is moving under gravity, it will have same downward acceleration, constant acceleration, and it will follow similar kind of trajectory. Similar principles will apply. Same, we can break down motion into two parts. So again, it is same thing. Only thing what happens in this case, since in this particular case, if we consider only part of oblique projectile from horizontal for highest point onwards, it is a horizontal projectile motion. That's what you have seen. Now, if we break it down into two parts, in this case, since the motion is only in the downward direction, from this point, since the velocity is horizontal, it will not go further up. It will only go down. So it makes more sense to choose x-axis in the horizontal direction and y-axis in the downward direction. So that's one change we can make. Rather than choosing x and y the way we normally choose, we can choose y-axis in downward direction. And the reason I've chosen downward direction, so we also understand here, moment we take in the downward direction, the sign convention, what we apply to vertical motion also will change. Earlier, upward direction was positive vertical direction. Now downward direction will become positive. Okay. So if I write what is the 1D motion in x direction, see, as we been mentioning time and again, when we break it down into two parts, three parameters are relevant. What are those three parameters? Initial position, initial position, velocity, and acceleration. So here also in x direction, initial position is origin. And initial velocity, let's call it as u. This is the speed of projection in the horizontal direction. And in this case, like previous cases, acceleration is ax is 0. Only change what will happen in case of y direction motion. Since projectile is projected in horizontal direction, definition of horizontal projectile, uy will become 0. And you notice what here? Ay becomes positive. Why it has become positive? It's not that direction of gravity has changed. It's not that direction of gravitational acceleration has changed. We have changed our convention. So always keep in mind, G is neither positive nor negative. G is directed towards center of Earth, which any particular place on Earth is vertically downwards. And depending on what sign convention we choose, it could be positive or negative. Okay. So 1D motion. So suppose it is projected from a point from height h, and it hits the ground. So we start from here, and this is something. So we go to similar parameter. We are just comparing this projectile motion also with oblique projectile. There also we have height and we have range and time of flight. So here also, if we look at the time of flight, we have seen time of flight. Time of flight is what is happening here. Time of flight, previous case also dependent only on y direction motion. Here also depends on what determines time of flight. Time of flight is suppose it is projected from height h. The time of flight depends on when does displacement in y direction becomes h. So this height affects the time of flight. So this also affects only y direction affects the time of flight, which is equal to time to fall by height h. And h is equal to 1 by 2 gt square. We get this is the time of flight, root of 2h by g. Okay. Now question comes up, what would be the range here? The range also, so again, in takes a y direction. We know these are the terms here. Now we put motion in y direction, we got to get this expression. Now we're coming to range part here. Okay, the same things are there. Time of flight we arrived at. And when it hits the ground here, when it hits the ground, what would be the velocity here when it reaches this point? Once we have known the time of flight, we can find out velocity, or otherwise also, I think some of may recall, even from work energy theorem also, any object will fall by height h will acquire a velocity equal to root 2 gh. So when it hits the surface here, velocity y component of velocity is equal to root 2 gh. And many times they ask, what is the angle at which the particle will strike the floor? And angle may be asked maybe from horizontal or from the vertical. If angle is from the horizontal, it will be y component divided by x component. If it is from angle is measured from the vertical, tangent of angle will be, it will become reverse. Okay. So this is what, so range is what? Range will be equal to displacement in x direction in time t. And displacement in x direction in time t, like previous case also, if this is this no acceleration here, keep moving the constant speed, and the range will be equal to u into t. So that becomes my range expression. So very simple. And the angle at which it hits the surface, tangent of that angle will be equal to, we are measuring angle theta from horizontal, it will be equal to Vy into Vx. Vx will remain unchanged as Ux. It will be root 2a by u. So that's a angle at which it strikes. And these are the only relevant parameters in case of horizontal projectile motion. Initial just what are changes we have made? We have only made y direction, we have taken downward positive. We could have taken upward also positive, it would not make any difference. In that case, what will happen? Displacement as well as acceleration both will become negative, and velocity y component also will become negative. If we take a downward direction, all terms become positive, all parameters in y direction are positive. So we understood again. So what is time of flight? Time of flight is equal to time it takes to fall a distance h, and we can easily find out h is equal to 1 by 2 gt square. So that becomes time of flight because root of 2h by g. When it hits the surface here, what will the component of velocity? X component will remain unchanged. Either I can write the y component will be equal to g into time of flight, or we can write as 2gh. It comes to same thing. And angle at which it hits the surface here, what is the velocity angle once it has fallen from height h? The angle also we can easily find out. Tangent of angle with horizontal is equal to Vy by Vx is equal to root 2gh by u. So these are the three simple parameters, practically nothing new. And in terms of formula also, I don't think any formula need to be memorized. We can find out time of flight if we keep this simple logic in mind. Time of flight is equal to vertical displacement of h is starting from rest. So we simply write h is equal to 1 by 2 gt square. We get time of flight and we get range. So no new formula necessary. Some of you want to memorize. Okay, if you have too many formula, it becomes difficult to memorize. So this is not, I think, among the formula which I recommend for memorization. Let's look at some simple question. And horizontal projectile questions may not be very tricky. So a very common example is, say any plane is flying horizontally at a speed of 100 meters per second. It releases an object which reaches the ground in 10 seconds. At what angle from the horizontal it will hit the ground? So first, what few things. So this is where the plane is flying, and what are things we need to keep in mind. And as it's plane flying, it is flying with the horizontal velocity. So angle of strike. So here we have to find at what angle with horizontal it hits the ground. So angle is to be measured from here, and whenever measured angle from the horizontal, y component in the numerator, x component in the denominator, and this will be Vy. So here it hits the ground after 10 seconds. So very easy. Vy will equal to 10 into g after 10 seconds, and Vx will remain u, which is the angle which is elastic given here. What are the important points we need to keep in mind? And I'll keep repeating this point many times so that we don't make a mistake here. If the object is released from the plane, at the instance soon after the release, the object velocity will be same as the plane velocity. So whenever word release means it will have same velocity. And unless we have used it is projected from the plane, sometime we can also use the term it is projected forward from the plane. In that case, velocity is different. It means before it is released, it is given with thrown, something like that. Suppose in the same question, if I reword a plane flying at 100 meters a second, an object is projected forward. Object is projected in a forward direction at relative speed, at a speed relative to plane equal to 50 meters per second. In that case, what happens? Soon after it is projected, it would have a horizontal speed of 150 meters per second. And that will little bit we see in the relative motion. It can also happen it is projected in perpendicular direction. So unless we use the word, it is thrown or projected from a moving body. If it is released, it will have same speed as the speed of the body from where it is released. Okay. Other thing what we notice here, suppose when we release here, if the plane continues to move in this with the same speed, it doesn't change the speed. Whatever speed it had, the moment it has released, it keeps moving the same speed. What we notice here, the speed of the plane and horizontal component of speed of the object which is dropped from the plane, both are same. So in equal time, they will travel equal distance. So let's say, suppose that after time t1, after time t1, this object would have moved in this direction by distance equal to u into t1. In the same time, if the plane has not changed speed, plane also would have moved here. So what will happen in this case, and after time t2, when it has fallen here, the plane also, by the time this has so much of horizontal displacement, plane also will have the same displacement. So if we look from the plane, this object will always appear vertically below the plane. That would happen if the plane is moving in the constant speed. Now, if I ask the question, what happens if plane after dropping is start accelerating? If it starts accelerating, then the object will fall behind the plane. If the plane deaccelerates, it slows down, in the plane where it will fall, it will appear to be in the front of the plane. That will happen only when we change the speed. If the speed is not changed, the x coordinate of the object which is dropped from the plane and the plane will remain same. It will always appear vertically below the plane. Very simple points. Next one. A body is thrown horizontally from a tower 100-meter high. So there's a tower here, and the height of the tower is 100 meter. And it's a very simple question, and all of you think it over. I'll ask some of you and expect you people to respond now. This tower height is 100 meter. So high tower, it is thrown with the velocity of 10 meter per second. Horizontally, it is thrown. After what time interval will it be moving at an angle of 45 degree? When we say angle 45 degree, we don't have to specify whether angle is measured from horizontal or vertical. Otherwise, we need to mention angle is measured with reference to which line. So this question can be answered very easily. It can be answered without even putting pen to paper. And I think most of you should be able to answer. Okay, let me ask some of you. At what time? Okay, who would like to answer? Advay, after how much time will it be moving at 45 degree?
Still working it out, sir.
No, there's no working out. I told you, there's no working necessary. You can just look at the question and answer. So still something is not clear. 45 degree. What is special about 45 degree? What has to be the x component and what has to be the relationship between x component and y component, Advay? 45 degree. So if this is ux and this is uy, both have to be equal. Okay, so Advay is not still taking time.
Okay, got it now, sir. Got it.
Yeah, tell me what is the answer.
I was going with the equation. 1 second.
That's why you don't go the equation. Look at the question and try and think logically. Tell me what will the answer. See, moment I say 45 degree, what should come to your mind? Horizontal component and vertical component have to be equal. And horizontal component is 10. So let's again I repeat this point. Moment 45 degree, horizontal component and vertical components are equal. Horizontal component will not change, it will remain 10 only. It means vertical also has become 10. After how much time the velocity in vertical direction become 10? Since acceleration is 10, it will become 10 after 1 second. Advay?
Yes, sir.
Yeah. So had I mentioned this question rather than 10 seconds, suppose I make this is 30 meter per second. After how many seconds it will become make an angle 45 degree, Advay?
3 seconds.
3 seconds. So this is something not only tries questions mathematically, also try and understand what is happening. And so this is something I hope all have followed. This is a pretty simple one. And this kind of question we should answer very easily. And if I have to do in terms of mathematical relationship also, what I would written, even then also takes very little time. Tangent theta is equal to y component divided by x component. Y component after time t becomes gt, and x component remains unchanged. Vx will be same as u, and this has to be equal to 1. Very easily you get an answer, even here also. It shouldn't take any time at all. So next question. So this question, all of you work it out. This question, as I said, today also there's absolutely nothing new. The same old concept, we slight different context we apply. So please solve and raise your hand as soon as you're done. Only 7 people have an answer. Okay, rest of the people also. Just look at this. Okay, so moment we hear the word horizontally means it's horizontal projectile question. Distance between buildings 30 meter. So it means when it enters the window of the next building, the range has to be 30 meter. So that is what we need to understand. So horizontal projectile, two things are relevant, H and R. So from this height, what is the vertical distance it falls? It starts from a point which is 150 meter above the ground. It enters a window which is 25 meter. It means the height has to be equal to 125 meter. That's all. Height is equal to 125 meter. Now, what could be the possible variation of the question? Sometimes we can also say there's a window which is 10 meters tall. What is the height of the window? There's a window here. The height of the window is 10 meter. And lower part is a certain height, upper part is certain height. In that case, what is the range of velocity I should have so that it enters the window? That becomes slightly tricky. You understand what in that case, what will happen? I will have two value of height. One is to the upper end of the window, other is the lower end of the window. In that case, if it has to enter a window which has certain height, you will come across a range of velocity at which it must be thrown. And you can think of this question is similar to if you had two other building. If your friend is there in another floor somewhere here, what is the speed you should throw so that this ball can be caught by your friend here in the other building? So that's okay. Height, once you figure out height is equal to 125 meter, root 2h by we find time of flight is 5 seconds. From the moment into your throw, it reaches here in 5 seconds. In 5 seconds, travels a distance of 30 meter. Hence, the speed is equal to 5 meter per second. So fairly easy question. Okay. Okay. Now come to next question. All of you read through next question. Just we understand here in case some are not clear. Okay, so just try and imagine what does projecting something perpendicular to direction of motion. Imagine you are traveling, just to give an idea, imagine that you are traveling, just we are looking from the top, you are traveling in a car or a train, and you are traveling in the north direction. This is how your car is seen moving towards north. Okay, so if you are traveling the speed of 10 meter per second, and imagine you have a toy gun, and the toy gun, you can have orientation of toy gun in the forward direction, you can have in the backward direction, we can also aim the toy gun in the perpendicular direction. If you hold the barrel of the toy gun at an angle which is perpendicular to direction of motion, so whenever this toy gun fires a bullet, let's say this velocity, if assume that if you are stationary in the car, if you are in the stationary in the car, the bullet would have moved towards east direction. Okay, now you are doing the same thing from the moving car. So moving car gives an additional velocity of 10 meter per second in the north direction, but since the gun is aimed towards east, it will also have a velocity in east direction. So which direction the velocity is relative to the car? This is in the direction in which the gun is aimed. That's what this question is normally. So that's what you say here. So if the car is, I hope this is clear. So the direction relative to the car, if it is stationary or it is in motion, relative car depends on which direction you aim the barrel or the gun at. If gun is aimed like this, that's what it means. So rest all is fairly simple here. Motion in 3 dimension, 3 independent 1D motion. What we write in x direction will be 10 meter per second, x will be 0, acceleration only in vertical direction. What would y direction, sorry, I made it in the mistake, y direction written should is 5 meter per second. Just make a correction. Y direction is 5 meter per second and ay is 0. I think I made a mistake somewhere writing. Okay, so I misread it. So this is 5 meter per second, and what will happen in z direction? Initial velocity in z direction is 0. Velocity is only in horizontal component, it has no vertical component. And since I have taken z direction as downward, z direction, this is value of z. So these are the velocities. And if I say, what will be the time of flight? What is the time it will hit the ground, which is 5 meter below? Can we tell what time it will hit the ground? Okay, let me ask some of you. Pranav Soma, are you there? Pranav, not there.
Yes, sir.
Can you tell me how much time will it take to hit the ground? And hitting the ground will depend on motion in which direction? First thing you tell me. X direction motion will affect.
Hitting Z direction.
It will depend only on Z direction. Is it not? The ground is in vertical direction, and what displacement it must have to hit the ground?
Downward vertical.
How much displacement? So how do I find how much time it will take to hit the ground? It has to travel a distance of 5 meters, because ground is 5 meters below. It means the displacement in that direction has to be 5 meters. And how much time it will take from here, I can easily find out. So what has to happen? Displacement has to be 5 meters. S is equal to ut plus 1 by 2 at square. Initial velocity is 0 here, it is given. So it will be 1 by 2 10 into t square, which is nothing but 1 second.
1 second.
It will take 1 second to hit the ground. Are you clear now?
Yes, sir.
Once we have 1 second, we can calculate all the displacement, all velocities. It becomes extremely easy to solve. Okay, I think I made a mistake. I wrote it, but this is 10 I wrote. So that's a error. You can note this correction here. So otherwise, even 3-dimensional motion also we can solve. Okay, and though this kind of questions are not very common, but even a simple question comes, we should be prepared. Okay, I hope this is understood. Bhageshri?
Yes, sir.
Easy?
Yes, sir.
Okay, one Shri is okay. What is other Shri? Dhanashri?
Sir, after you explained it, it's easier.
But no, see, what is the purpose of explaining now? Any question which comes in 3 dimension, this is not explanation, is not for this question alone. Explanation is how to handle question involving 3 dimension.
Yes.
So can you apply this concept in any similar question? That's the point here. Can you do that?
Yes, sir, I can now.
No, so that is point with this. So purpose is, so we take one type of question and anything similar approach, we can solve it. That's what our issue be, our aim should be, right? Okay. Now, next question. This is fairly simple question. All of you should be very easily able to solve. Lakshita, done all the thinking?
So I have this thing. Can we use the relation between height and range for this question?
So our horizontal projectile, what are the things which are relevant? Only things relevant are what is the vertical, what is happening in the vertical direction, what is happening in the horizontal direction, and what is the time of flight. So if it has to cross point B here, what is the vertical displacement? It has to have vertical displacement of 10
meters.
So it takes certain time. So what is time? Time is to reach a point here near, it has to have a vertical displacement of 10. And it will take a particular time t for that vertical displacement. That becomes time of flight. During that time t, so by the time it has a vertical displacement of 10 meter, its horizontal displacement should be 40 meter or more. That's all my equation is. That's a common sense understanding. Even person not knowing anything about physics also should make okay. So it has from here, by the time it falls 10 meter in the vertical direction, its displacement in horizontal direction should be greater than 40.
40 meters,
right?
yes.
What is time of flight? So by the time it falls 10 meter, that's the time it will take to fall 10 meter. Using this 9.8, g is equal to 9.8, 10 by 7 seconds. During this period, it will travel a distance ut, and the ut has to be greater than 40. Then what will happen if ut is greater than 40? The point it will like this. By the time it travels 10 meter, if it is say 41 meter, it will be here. If it is 39 meter, it will be here, kind of thing. And similar kind of question, a variation of the question could be something like this. What could be the variation of the question? A person is standing here, and suppose there's a boat here, and boat has a length of whatever. The boat has a length of say 10 meter, and nearest part of the boat is at a distance of 30 meter. We can also ask what is the range of u you should have so that the ball lands up in the boat. How would you solve in that case also? If the boat is at the water level, and what should be the range of velocity so that the ball lands up in the boat? So we know there also we have time of flight. During that time of flight, range should be more than 30 meter, less than 40 meter. So those questions also we can easily, similar logic we can solve. So any such variation where range is also involved, we can solve. Okay. Now coming to next part, which is projectile and inclined plane. Okay. And inclined plane, so far I haven't seen any question coming in mains. It doesn't mean simple questions will not come. Only thing I can, from the fact that questions on inclined plane have not come, I think if they pose a question on inclined plane, it will not be too lengthy one, it will not be too difficult one. So if we expect question, it may be simpler question on inclined plane, and that's what we'll practice on. We'll do some few questions, and if you do it properly, I think that many questions are adequate to understand projectile motion on inclined plane. So let's look at the first question. And first question. So you have first question. It can easily be done in less than 2 minutes. So all of you give it a try. Let's see how when we say another different wordings may come. One wording is like this: it hits the inclined plane perpendicularly. What do we interpret from this? It strikes the plane perpendicularly. Can you think of RH? What does this mean? And how would I convert in form of mathematical relationship? It strikes the plane perpendicularly. What do I understand from this?
It hits the plane at a 90-degree angle.
90-degree angle. So what makes 90 degree? This line, I see when you talk about 90 degree, there are two directions involved. One is surface of the inclined plane. There's something else. What is making 90 degree? Displacement is not making it. Huh?
Velocity vector.
Velocity. So at that instance, there's a particular instance when it hits the floor. So at the instance, it strikes the inclined plane. At the instance, it will always hit not in time interval. It will hit an instance. At the instance, it hits the plane. Velocity will have a particular angle, and in case of a projectile, its direction of velocity is continuously changing. So at the instance hits the floor, hits the plane, the direction of velocity, which is at that instantaneous velocity, direction of velocity is perpendicular. So if this angle is, if the plane makes 45 degree, it means this angle is 45 degree. Velocity vector also will make a downward angle of 45 degree with the horizontal. Then only it will hit the plane perpendicularly. Is it clear now, everyone?
Yes, sir.
So that's one way you can say hitting the plane perpendicularly, which means it gives you direction of velocity at the instance it hits the inclined plane. That's one way. When we say it hits horizontally, what does it imply now? Now you should tell me, what does hitting the plane horizontally mean?
It hits the plane at an angle 45 degrees from the horizontal.
Or I will tell it the other way. It hits the plane horizontally means at the instance it hits the inclined plane, its velocity is horizontal. Does it make sense? So it travels, it hits the plane horizontally. So how is it traveling? It tells you if this is the path it takes, and this comet hits the floor here. At the instance it hits the surface inclined plane here, its velocity is horizontal. Is this word? Do you think this word means this or not?
Yes, sir.
Yes, and so that's what this wording means. At the instance, every time it will hit a particular instance, at the instance it strikes the plane, direction of velocity is horizontal, or velocity is horizontal. Now we solve the question. Now it becomes extra, it should become very simple. So unless these are things we can come across in case of inclined plane. How does it hits any surface? It can hit it perpendicularly, it can hit at an angle, it can hit horizontally, it can hit vertically also. Vertically means what? Okay, it hits perpendicular and vertical are different things. It hits vertically means the direction of velocity at this distance is like this, which normally won't happen, which happens in some collision cases we'll see later. So if the velocity direction is this, we can say when the ball hits the floor, something like this, it will say hitting vertically. This is hitting vertically, and this is hitting horizontally. So when this does, it hits horizontally. So now someone has an answer?
1 by u, right?
Yes. Well, how?
When it's sitting horizontally, it will be at the highest point.
At the highest point. That's all we have to keep in mind. So basically this question, is this question a inclined plane question? No, we can solve it without using anything related to inclined plane. All the point where the particle strikes the inclined plane is its highest point. At the highest point only velocity becomes horizontal. Okay, so this is a point we have to understand. Is this point making some sense here? I hope this point is clear to all of you. Vikram? Vikram,
Yes, sir.
is this clear?
Yes, sir.
So what is this point here? So this point corresponds to, if I take, so this particular projectile, if maximum height of this projectile was h and the range was r, and if I take this origin, what would be the coordinate of this point? What would be the coordinate of this point at the highest point? Coordinate of highest point, h by h and r. So that's what you have to keep in mind. Since the highest point of trajectory, so basically it means highest point of the trajectory lies on the plane inclined at 45 degree. It means h by r, tangent of the h by r is equal to tangent of 45. Tangent of 45 is calling h by r by 2. The highest point, this is the coordinate, x coordinate will be r by. So this, you take the path like this. This point, this is h, and this one is r by 2. And since it lies on the inclined plane, so h by r by 2 will be equal to tangent of this angle. So tangent of 45 is equal to h by r by 2 is equal to 1. And if I substitute h value, what is h value? H value is equal to uy square by 2g, and r is equal to ux uy by 2 ux uy by g. If you substitute, we can easily find the value of theta. So is this a question on inclined plane? No, it is not a question on inclined plane. It comes a root 2 or it comes as 2?
I got 1 by u, sir.
See, you got 1 by. Okay, let's do that. So is this part clear so far? Let's do that. Okay. So what is h equal to? I will do everything in ux and uy only. What is h equal to? Uy square by 2g. And what is r equal to? R is equal to ux into 2uy by g. So let me put this value h is equal to r by 2. You equate h is equal to r by 2. U square by 2g equal to 1 by 2 of r, which is equal to ux into 2uy by g. Okay. So what are we left with? Ux, uy by gone, g and g gone. What are we left with? Uy by ux is equal to 2. What is ux by uy is equal to? What is ux by? That's tan theta.
Tan theta.
So tan theta is equal to, not as I think this was noticed that, not root 2. I did not type out. This has to be 2. So are you clear about this? Who is getting something else?
I missed a u, sir, in between.
No, you, because see what happens when we write that this term has to be dimensionless, that u term cannot come. No, there has to, terms has to cancel out, because the tangent angle we take the ratio, it has to be dimensionless. Okay, right. And the reason I did this one also, no formula. I just use very basic things and you can get all the answers. Okay, next question. And this question can be solved in two different
In terms of u and g.
Huh? Yeah, of course it will
In
come in terms
terms
of
of
u and g. It's a variable question. It will come in form of u and g. You see, all distance has to come in terms of u square by g kind of thing, is it not? See, all
Yes, sir.
distances have to come in which form?
U square by g.
Yeah. Okay. So one way of solving the question would be whether this is something, okay, I'm solving, okay, suppose the question was, I'm solving in whenever it strikes the surface after time t. So at time t, it strikes the surface. And I'm taking x direction, y direction. So in terms of coordinate, this particular point, Hemant, you have an answer?
Yes, sir.
Very good. Okay, so this is in time t, xt. And so this x coordinate and y coordinate by x coordinate is equal to tangent of 37 is 3 by 4. What will be the y coordinate? That is displacement in time t, 1 by 2 gt square, and this will be ut. I get the value of t, 1 by 2 gt square by ut. And from there, I get the value of t. Okay, t comes 3u by 2g. If t comes 3u by 2g, x coordinate of point of impact will become equal to u into t. It becomes 3u square by 2g. So this distance will be equal to 3u square by 2g. I think some typing, I don't know what is this is 3 by 4. I think I was typing something. 3u square by 2g. But when I want inclined distance, if this is range r cos 37 is equal to x. So r cos 37 is equal to 3u square by 2g. So let me put this value. R cos 37 is equal to X. I get R value is equal to 15 U square by 8G. What is your answer, Vignesh and Hemant?
Same, sir.
Same. Okay.
Yes, sir. Same.
Same. So that's one way. We had done nothing. We just used same horizontal projectile. So we could have done as a part of horizontal. Can we think of other ways of solving this question? This one approach. What is the other approach you can use to solve the question? This approach, I hope some of how many? Anish, is this understood?
Yes, sir.
Pranav,
Yes, sir.
are you clear about this part also? How did you get this part? Pranav?
The X component.
Yeah, basically, see, if this distance is, this is R, this is X, and this is Y. Is it not? This is what we are
Okay.
used. What is X? This is where the particle is at time t. It means in X direction it had displacement of X. In Y direction it has a displacement of Y. Since at time t it strikes the floor, Y by X has to be equal to tangent of 37. That's what we are using.
Yes.
Okay.
Understood.
And we find time. So in time, once we have found time is so much, we know how much X will be. So we could have calculated X and Y and taken root of X square, Y square, or since we have this value of X, R will be equal to X sec theta, sec 37, or same thing written here. Okay, that's one way of solving the question. Can we solve in different way? Yes. Other way of solving is where we can take X axis along the slope, as we had done in case of usual projectile. In usual projectile, what we do, whichever surface, that a surface which is, just imagine you tilt your head. Now, if I keep my head tilted here and keep my eyes in the same level aligned with the inclined plane here. So you can take other way of solving the question is I take the X-axis along the surface and Y-axis perpendicular. In that case, what will happen? Again, if I calculate time of flight, displacement along X-axis during time of flight, and this will hit the surface here at time capital T here. Capital T strikes here. So in this case also, again, I can solve question. You can resolve the two component, X component and Y component. I can calculate time of flight. Time of flight will depend on motion in Y direction. After I find time of flight, the range will be equal to displacement along X axis in time capital T. So two steps similar to approach what we use in case of normal projectile. We take into two components. Only important point is when we can, how do we solve that one also. So this is something all of you should try and solve on your own. And if you can solve on your own, that's a very good proof that you have understood how to resolve things properly, how to write equations properly, and how to arrive at solutions. So can we all try using this method as well? So first thing what we need to do, only hint is write your 1D motion along Y-axis. Once you write the motion along Y-axis, it will help you find out time of flight. Time of flight will be equal to 2uy by ay. And once you find time of flight, we can calculate displacement using motion along x-axis, ut plus 1 by 2 at square in time t. That's the range. And all of you should be able to do that. Okay, so this is part of the work. I think by the time we have next session, all of you try and do it. And a similar one or two questions we'll do in the next session also.